So we're going to take a look at the components of a linear function. So let's take an arbitrary x1 and x2. Well, then the distance between those x values, or our run, is x2 minus x1. They have corresponding y values, y1 and y2, and the rise, or the distance between the y values, is y2 minus y1. So we get our slope calculation, which is y2 minus y1 over x2 minus x1. That'll give us the slope of a linear function. We can think of it as a triangle that has a height that's equal to our rise and a base that's equal to our run. Notice, wherever on this line we look at the triangle, it's always at the same angle. In fact, if we were to increase the triangle, we get a similar triangle, so while the rise and run are not the same, the ratio of the rise over the run will still be the same. That's what it means to be a linear function. The other component we have is the place where it hits the y-axis, called the y-intercept. Let's say this one hits at 0, b. That means it's b units above the x-axis. Well, that gives us the two components that make up our linear function, or give us our basic formula of y equals mx plus b. Let's take a look at an example with some actual numbers. So let's use the x values 1 and 3.8. So the change in x values is 3.8 minus 1. That's our run. The corresponding y values are 3 and 5.8. So 5.8 minus 3 is our change in y, or our rise. Taking our rise over our run gives us our slope. In calculating, we get 2.8 over 2.8, which means we have a triangle with a height of 2.8 and a base of 2.8. Notice, no matter where we look, we have a triangle with a ratio of 2.8 over 2.8, or a slope of 1. Like last time, we can increase the size of our rise and run. We get a similar triangle. And now, if we look at our change in y values over our change in x values, and do our calculations, we see that we still get 11.3 over 11.3, or a slope of 1. So, no matter where we look, this line has a slope of 1. Now we want to fill in our y equals mx plus b. Our m is 1, because that's our slope. We also need where it hits the y-axis. Well, this line hits at the point 0, 2, and putting this together, we get the linear function y equals 1x plus 2, or just y equals x plus 2.